All right, today's notes are going to be on the quadratic formula. Our objective is to solve quadratic equations using the quadratic formula. Now, when we talk about the quadratic formula, which is below, right here, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. However, this formula can be used if my quadratic is put in standard form. And we've talked about standard form basically just going from highest degree to lowest degree. So make sure when we talk about the quadratic formula and you go to utilize it, you want to use it after you've gotten your equation into standard form. All right? Now, the reason why we use the quadratic formula is to solve any quadratic equation. So anything with an x squared, I can use the quadratic formula. But it's most useful if it cannot factor and also if the problem has imaginary solutions. My solutions are going to be the x-intercepts of the graph. So if I have, answer of, let's say, -1 and 2, that would stand for where the x-intercepts are of my graph. So my solutions are also the x-intercepts of my graph. If they're rational numbers, like -1 or 2, I could have factored that equation as well. So sometimes, yes, factoring is probably simpler. So typically if something's factorable, you want to use that method first. Now, if your solutions are irrational, they just mean they're going to be decimals. So your answers might have been, something here and here that weren't integers. Maybe they were the square root of, negative square root of 2 and positive square root of 2. So those would be irrational. But when you solve by graphing, you would get decimal solutions. You could solve a problem like that either using the quadratic formula or by graphing. But the one where I would say it's most useful is if your answers are complex or imaginary. What happens when you graph an equation like that is it's not going to have any x-intercepts, but there still will be two imaginary or complex solutions to the problem, and the only way you could determine those is by using the quadratic formula. So we're going to do 4 problems and use the quadratic formula to determine our solutions and then talk about what those solutions mean. So looking at number 1, if I want to solve this using the quadratic formula, one of the biggest mistakes you guys make is not putting in standard form, because right now that 1 is on the other side of the equation. The first step I want to do is I want to make sure that I subtract the 1 over and set my equation equal to 0. So put it in standard form. Once it's in standard form, I'm going to scroll back up a minute. Your a value is the value that's the coefficient in front of the x squared. So like my a value is 3. My b value is the coefficient out front your x term, so my b is 2. And then the c value is the constant or what's by itself. So if I label a, b, and c, now all I have to do is kind of plug and chug throughout my quadratic formula. So I'm going to say x is equal to negative b, so -2 plus or minus b squared minus 4 times a times c, and the entire numerator is over 2 times a. So what I'm going to do is just simplify throughout and see how get the most simplified answer possible. So I'm going to have x equals -2 plus or minus. That's going to be 4. And then -4 times 3 is -12 times a -1 is a positive 12. All over 2 times 3 would give me 6. All right, so let me scroll down and get some more room. So I'm going to continue to simplify this and say, okay, -2, x is equal to -2 plus or minus the square root of 16 all over 6. And I know that the square root of 16 is really 4. However, if you have all integer solutions like that, like I have -2 plus or minus 4 over 6, I want you to go ahead and simplify what those two solutions are going to be. And what I mean by that is you kind of have a top root and a bottom root. Like I'm going to say, what is -2 plus 4? So -2 plus 4 would be 2, and then 2 over 6 would be 1/3. So one of my solutions is 1/3. Then take the negative or the bottom route. What's -2 minus 4? Well, that's -6. What's -6 over 6? It would give me -1. So the two solutions to my quadratic equation that I was given example 1 are 1/3 and -1. Because those are integer solutions, you actually could have solved this problem by factoring, all right? And what's nice about that is you can check your answer by factoring too, because if I did, let's see, 3x and x, 1 and 1, let's do minus plus, that would get me x is 1/3 when I solved, and x is -1, and that's exactly what I got when I solved by the quadratic formula. So there's an example of a problem that you could factor if you saw it, but if you couldn't factor it, you could always use the quadratic formula and come up with your solution. All right, let's look at number 2. So number 2, same thing, it's not in standard form. So go ahead and automatically move over that 10x. So I'm going to say 3x squared minus 10x plus 5. I'm going to put the 10x in the middle because this is like my b value. I want it to go in standard form from highest degree to lowest degree. So now I know my a is 3, my b is -10, and my c is equal to 5. So when I go to use the quadratic formula, negative b, if I do -10, it's going to be +10. Plus or minus the square root of b squared, so -10 squared is 100. I'll just redraw that. Plus or minus 100 minus 4, a is 3, c is 5, and I'm putting it all over 2 times a. So let's simplify that. X is equal to 10 plus or minus the square root. Well, -4 times 3 is -12. And -12 times 5 is going to give me 60. And this would be a -60. So underneath the radical, I'm really doing 100 minus 60. So that would be the square root of 40. And my denominator, 2 times 3, would give me 6. Now, I don't know, like 40 is not a perfect square, but I can still take the square root of it. Whoops, sorry. Let's scroll down. I have the square root of 40. I can still break up radical 40. So like on the side, I'm going to say, okay, what two numbers give me 40? Let's go 4 and 10. So it'd be 2 times 2 times 2 times 5. So I could pull out a 2, right? It'd be 2 root 10. So I'm going to simplify root 40 into 10 plus or minus 2 root 10 all over 6. Now, because these are all outer numbers, my 10, my 2, and my 6, since I can divide all of them by a common factor, basically I can pull out a common factor of 2 or reduce them all by 2, go ahead and reduce your answer. So reduce the first, second, and third term. I would say 10 divided by 2 is 5, plus or minus 2 divided by 2 would just become 1, so just root 10 all over 3. And when you have an irrational solution, just leave your answer like that. If you had to find the decimal, you would do 5 plus root 10 and divide that by 3 to get one of your solutions, or 5 minus root 10 divided by 3 to get your second solution. All right? So number 2 would not have been factorable. All right? So the quadratic formula was a great technique to use because I would have a irrational solution. Okay, let's try number 3. So number 3 doesn't start in standard form. Let's go ahead and, or sorry, it does start in standard form. So let's just go ahead and use our a value, our b value, and our c value. So x is equal to negative b, so negative 8 is positive 8, plus or minus b squared, negative 8 and negative 8 is 64, minus 4 times a times c, all over 2 times a. All right? So let's simplify that. X equals 8 plus or minus the square root of 64 minus, well, 20 times 6 is going to give me 120 all over 10. Let's simplify that further. I get 8 plus or minus the square root of 64 minus 120 would give me negative 56 all over 10. Now, typically, I cannot do the square root of negative numbers, but we talked about complex roots that I can simplify those and leave them as the square root of negative 1 will come out as I. So I'm going to take 56, and if I were to just have the number 56 and I were to break up that radical, 8 times 7, so what, 4 times 2, so 2 times 2 times 2 times 7. So we would have 2 root 14. So the issue is I not only have 2 root 14, okay, but I'm going to have 2i root 14. So let me take this, I'm going to simplify it to be 8 plus or minus, instead of just the 2 out there, I'm going to pull the negative out as I, so 2 root 14 all over 10. And because I have all three numbers are divisible by 2, I'm going to go ahead and make my final answer and simplify it and say, okay, this is divisible by 2, so is this and this. I'm going to say it's 4 plus or minus I root 14 all over 5. Now, if you look, because those are complex solutions, this would not appear on your graph. You could not have x-intercepts with imaginary numbers. So if you had a graph like this, what's going to happen is it's going to look something like, this is an example, where it would not ever touch my x-axis. So if obviously you couldn't factor, and if you graphed it, that still will not help you find the solution. So the best way to solve something like this would be to use a quadratic formula because it shows me my complex roots or my imaginary numbers. So those are three kind of different examples. One that's rational, one that's irrational, and one that's imaginary. Go ahead and try number 4. Pause your video, find out your solutions, and then come back and check your answer. Okay, so for number 4, I'm going to move the x squared over here. So I'm going to get x squared plus 6x minus 5 equals 0. My a value is 1 because the coefficient in front of x squared is 1. My b value is 6. And my c is negative 5. So x equals negative b plus or minus the square root of b squared minus 4a times c all over 2 times a. So let's simplify that. Negative 6 plus or minus negative 5 times negative 4 would be positive 20. So I would have 36 plus 20. So that's going to be the square root of 56 again, which is nice because we did that in the last problem. So knowing from over here, I know that that's 2 root 14. So 6 plus or minus 2, negative 6 plus or minus 2 root 14 all over 2. And so we can simplify that. I'm going to run out of room here. I'm going to go ahead and do it in red. Again, because everything's divisible by 2, I'm going to say it's negative 3 plus or minus root 14. Because this 2 will cancel with this 2. This will go and become 3. So my answer is negative 3 plus or minus root 14.